contains the tools, basically the zero-knowledge proof circuits and the smart contracts needed to run a zero-knowledge based NFT airdrop. So basically, as opposed to happen now where NFT artists or any organization manually collect the addresses of the user via Web2 platforms such as Twitter or Discord. In this way, you can basically do that in a privacy preserving way. So without exposing the Web2 identity of the user, without associating this identity to the Web3 wallet used to redeem the address. So let's jump into the code. First of all, I'm gonna need to start a local blockchain. I'll compile the circuits, which is gonna be used to generate the proof, the verification key. I'm creating the verification key, and last I'm gonna export a Merc verifier contract, which is gonna be used, which is a smart contract used to verify the proof provided by the user. Now let's deploy our contracts. There are three main contracts, as you can see: the NFT contract, the Plonk verifier, which is the one that I just exported from Circom, and the private airdrop, which is the contract which is going to be used to manage the airdrop and the verification. It's important to notice that the ERC-721 contract can be any standard compatible contract, and it can be also an already existing contract. So let's mint some NFTs. As you can see, I added some metadata to the NFT, such as the DAO name, the DAO role, but this is not strictly necessary for the functioning of this library. So these were successfully minting. So now let's say that I'm the airdrop issuer, and I want to collect commitments from the users via Discord, for example. User can basically privately generate the nullifier and the key, which basically are just some random 31 bytes number, and hash them together to generate the commitment. And this commitment is gonna be basically publicly stored in this file, and from this list of commitments the airdrop issuer can generate a Merkle tree, and the root of this Merkle tree is going to be stored in the airdrop contract to basically manage the airdrop. So let's do that. Basically, by doing that, as you can see from the output now, a new commitment has been generated from a user starting from this private nullifier and key, and as you can see, the public list of commitments gets updated, and also the Merkle root on the private airdrop contract gets updated every time. We can do it a few times to simulate some commitments, some user providing their commitments, and that's it. We now have 3 commitments stored. So let's say that I'm one of these users that created the commitment. So for example, this one, the last one. Now I want to generate the proof to basically claim and redeem my airdrop. It's important to notice that everything here happens what happens off chain in this script to generate the proof called data, and there's no transaction, on-chain transaction involved. So any of these of this any of this action happens off chain. So let's generate our proof data. It's gonna take a while because it's a very intense operation. So basically, as you can see, it will take what happens? I think I didn't save the so let's see if it's able to generate the proof. I guess I didn't save the new public commitment list previously. Okay, here we are. We have our proof, and we also have our key hash, which is basically need to be used to make the smart contract call. So then here I am. I pass the proof. I'll pass the nullifier hash, which was wrongly named key hash, and also I need to retrieve the airdrop contract. Yes. So now I can run the collect function to let's see if everything was correct and the proof can be successfully verified. Okay, so the proof has been verified, the NFT has been collected, and once again, the important thing to notice here is that the airdrop, the verification happens without associating the collector address to the commitment that he previously provided. So the zero knowledge component here is that the collector can prove to the contract that he made the commitment without actually telling the contract which commitment was here. And here's the cool part. I hope that you liked this library, and feel free to contact me, to reach me out on Twitter or on GitHub to understand more and to work on this stuff together. Thanks.